All right, greetings everyone. Welcome to the second part of the video now for section 5.5. Continuing on with our study of right triangle trigonometry, we'll now look at an application problem related to this. So here is the scenario. You walk 40 feet back from the base of a tree and measure the angle of elevation to the top of the tree from the ground to be 72 degrees. And we're supposed to use that to find the height of the tree. Now, for this problem, we're going to use a very powerful and very old mathematical trick to help us see what's going on here. And that very old and powerful trick is to draw a picture. Okay, anytime we have a situation like this, a picture is often helpful. So I'm going to go ahead and do that. So this here is going to be my tree. And yes, you can keep your judgments about my drawing here to yourself. You know, I teach math, not art. And here's the idea is you go 40 feet back from that tree to some distance here. So call that 40 feet. And then here is you. And then it says from the ground, which we'll imagine this is the ground here, we measure an angle of elevation to the top of the tree. Now, what could that mean, do you suppose? If it's from the ground to the top of the tree. As you can imagine, for your line of sight, or actually we're going from the ground here, up to the top of the tree, it might look something like that. And then we're told that the angle of elevation, well, that's going to be the angle above the ground right here, is going to be 40, or sorry, not 40 degrees, 72 degrees. And hopefully you noticed what we've gotten here within this drawing is a right triangle, right? Because we can think of the line of sight to the top of the tree is one side, the height of the tree is another side, and the distance along the ground is a third side. And it looks like here in the corner we would have a right angle. And actually, you know what? I did not draw that correctly because we're doing from the base of the tree, right? So actually it should look more like this. Okay. And in that right triangle, we see that that bottom side there has a length of 40 feet. We have this angle of 72 degrees. And then we want to find the height of the tree, which is going to be this side of the triangle here. And again, we've got the right angle here. So just like we did on the last problem on the previous video, you just want to identify how these sides relate to the angle. So here's the angle. We see this 40-foot side is right next to it, and it's not across from the right angle. So that means this would be the adjacent side. The side that's the H here, well, that's across from the angle, so that's going to be our opposite side. So it looks like we're dealing with opposite and adjacent, which tells us we could set up a ratio using tangent of 72 degrees. Would be equal to the length of the opposite side, which in this case is H, over the length of the adjacent side, which is 40. And then we can simply solve for the value of H. So we'll multiply by 40 here, multiply by 40 here. These can cancel. So we have H equals 40 times tangent of 72 degrees. We can go ahead and plug that into our calculators. And it looks like we get that the tree is 123.107 feet tall. Okay, so that's a nice application of right triangle trigonometry. And again, the key there is setting up a picture, some sort of diagram to help you see what's going on. All right, last thing from this section, I just want to talk about the difference between an angle of elevation and an angle of depression. So we actually just saw an example of angle of elevation. So notice here, whoops, in this picture, okay, we see the angle of elevation. Here's the horizon, this dotted line. The angle of elevation is a angle above that horizon, which when I hear the word elevation, it often makes me think of mountains. Mountains have elevation. You have to look up at them. So that's how I remember the angle of elevation is the angle above the horizon. And then the angle of depression, well, that's going to be an angle below the horizon. So in that case, this would be this angle y here. So notice that it's measured as an angle below that horizon there. So that'd be your angle of depression. And my way of remembering that, this is a little bit morbid, but you know, if you're someone who's feeling down or maybe feeling depressed, you're probably going to be hanging your head, which means you're going to be looking down. So that would be the angle of depression. Okay. All right, that's it for now and for chapter 5. Thanks for watching.